Hey everyone, welcome to WittCode, where in this video, we're going to Dockerize a React application for both development and production by using Docker and Docker Compose. We'll also learn about Docker containers, Docker images, and more. So before we begin, why should we containerize a project with Docker? Well, Dockerizing a project is a good idea because it solves the "it only works on my machine" problem by providing a consistent and isolated environment. Docker does this by using Docker containers, which allow us to package an application into an artifact that can be distributed and ran in different environments. For this video, we will containerize a React application created using the module bundler Webpack. Here, Webpack is using Babel to convert JSX code to code that the browser understands. We configure Webpack with a few configuration files titled webpackconfig.js, webpack.dev.js, and webpack.prod.js. The link to downloading this code will be in the description. But so, the file webpack.prod.js is for working with the React project in production, webpack.dev.js is for working with our React application in development, and webpack.config.js contains the commonalities between development and production. So to first get started, let's create a Docker file called Dockerfile.dev to the root of our project to assemble a Docker image. We can then use this image to develop our React application. Docker builds images by reading the instructions placed in Docker files. On the first line of our Dockerfile.dev file, add the command from node alpine. Docker files must start with the from instruction to initialize the base image for subsequent instructions. A base image is an image that is used to create container images. These base images can be official Docker images, custom images, etc. Here, we are specifying that we are going to use the node Alpine Linux distribution to build the Docker image. Alpine is only 5 megabytes in size and has access to a very complete package repository. This makes it an ideal base image. We also don't specify the version of Node or Alpine, which will give us the latest available Dockerized version of each. Next, we want to set the working directory of our Docker container by using the work_dir command. Any run, cmd, add, copy, or entry point command used inside the Docker file succeeding this line will be executed in the specified working directory. We specify the working directory to be client here to match it to our host folder structure. But actually, we don't have this in this shape right now, so let's put all this inside a folder called client. And now the working directory will match the working directory of our application on our host folder structure. And now let's bring over the package.json file into the container and run npm i to install the required dependencies. We can bring files into a Docker container by using the copy command. The copy command takes the signature copy, source path, destination path, where source path is the path of the file on the host computer and destination path is the destination to copy the files to in the container, which when we set the work directory to client will be in the client folder. And we want to copy over our package.json file and install dependencies before copying over the rest of our React application so Docker can catch these layers. Therefore, when updating the source code of the React application, if package.json hasn't changed, it won't need to be recopied over and have the same dependencies reinstalled. Now let's copy over the rest of our project files using the copy.doc command. And finally, let's use the cmd command to run the start script in our package.json file. The docker cmd command specifies instructions to be executed when a Docker container starts. So now we've got our development Docker file set up. Let's work with our Docker file or production Docker file. So add a Docker file titled Dockerfile.prod to the root of our project to assemble a Docker production image. Our production Docker file will use a multi-stage build, and multi-stage builds allow for the creation of smaller container images with better caching. They achieve this by using multiple from statements. Each of these from statements can use a different base and bring a new stage to the build. The first stage of our production Docker file will be essentially the same as the development one, except we will give it the name build by using the as keyword. And now, as this is a build for production, we will run npm run build as opposed to npm start. And next, we will use nginx to serve up this production build. In development mode, we are just using the Webpack dev server, but that is not good for in production. For that, we have to use something like nginx. And nginx is a web server that is commonly used as a load balancer, but can be used for much more. To do that, we will make another build stage using the nginx image. Pull the nginx image by using the from nginx command. Then let's copy over our build folder from the previous stage and place it inside -user-share-nginx-html in the current stage. We will do this by using the -- from flag, which allows us to copy from a separate image. And so we copy to this directory here, as this is the default location nginx looks at when serving content. Placing an index.html file inside this folder will make the file instantly visible on port 80. By default, the nginx HTTP server listens for inbound connections on port 80. Now let's create a docker-ignore file to exclude certain files and folders from the build. This allows us to make a faster and lighter build. Add this docker-ignore file to the root of the project directory. Within it, let's place some commonly ignored files and folders. These files and folders will be ignored during the building of the Docker image. Now let's start working with Docker-compose, and we'll do this by creating a docker-compose.yaml file. So this project will only consist of a front-end React application, which is client. And we actually need to move this inside our client folder. So this project will only consist of a front-end React application, which we have called client, we can see here. However, in the future, we may want to add a node backend, a database, and so on. And as such, we should create a docker-compose.yaml file to allow us to deploy, combine, and configure multiple Docker containers at the same time. So create a docker-compose.yaml file at the root level of the project. This docker-compose.yaml file will not contain a whole lot of information, as it will be our base docker-compose file. We will have both production and development docker-compose.yaml files. But within this file, we will declare the commonalities between production and development. This is solely the name of the service and the build context. So, services describe each container's behavior. Each service has a name, and we have called our React service client right here. The build instruction is how we will build our Docker image. The context instruction within build specifies the location of our Docker file. Both Dockerfile.dev and Dockerfile.prod are present within the client folder, which is why we specified --client. This will be the only similarity between our development and production Docker-compose files. So we will configure our development services inside a docker-compose.dev.yaml file. Create this file at the root directory. Now let's declare our services the same way we did in our docker-compose.yaml file. We can declare the name of the image used to create our container using the image construction. Let's title our image client dev I. Now, along with specifying the path to our Dockerfile.dev file, we also need to specify the name of it, and this can be done with the key Dockerfile. Now, when this docker-compose.dev.yaml file is combined with docker-compose.yaml, the image will be built using the context .-client, which we can see here, and the Docker file, Dockerfile.dev, which we have here. Now, let's name the container created from this image by using the container name instruction. And we will name our container client dev c. And next, let's set up some volumes. And so a Docker volume is an independent file system that is entirely managed by Docker. Docker volumes persist the data generated and used by Docker containers by mapping a host directory to Docker's file system. Volumes are needed because when a container is removed or stopped and restarted, then the data is gone. For development, we want to create a volume that maps the client folder on our host machine to the client folder in the Docker container. We can do this with the volumes command and supplying it a list where each item is the host directory : Docker directory. Here, the host directory uses a relative path. So here we can see our host directory is .-client and our Docker directory is client. Now, whenever anything is changed inside the client directory on the host machine, these changes will be replicated in the Docker container. And also, there are different types of volumes. The volume we just made is called a host volume, as we match the file system on the host machine to a container. Another type of volume is a named volume, where we reference the container directory to a name. We will do this with node modules because we want to prevent the node modules folder from our host environment to overwrite the node modules folder within the container. The location of named volumes on the host is managed by Docker. And we want to do this because the node modules folder can cause issues if the container architecture is different than the host operating system that it is used for development. For example, running npm node sas on a host machine using macOS would install different dependencies than running npm node sas on a container that uses Ubuntu. Finally, let's set the node env environment variable inside the container to development by using the environment command. Let's also map our host port on 3000 to the container port 3000 by specifying the ports command. Now, when requests are made to localhost 3000, they will be forwarded to the container port 3000. But so this is it for our development Docker Compose file. Now let's work with a Docker Compose production file. So we'll call this file docker-compose.prod.yaml. This file will be similar to our development file, except we will use different ports, container, and image names. We will use the Dockerfile.prod Docker file, and we will set the node environment variable to production. As this is a production container, we won't set up any volumes with the source code. So that's it for our production Docker Compose file. Now let's create a bash script to run our Docker Compose files. Create a folder at the top level of our project called bin and place a file inside called deploy.sh. And now we need to make this file executable by running the command chmod u+x deploy.sh. Navigate to the location of this file and run this command in the terminal. And now let's start working with this file. At the top of it, add the shebang -bin -bash to instruct the operating system to use bash as the command interpreter. And next, this command will be ran by running .-deploy.sh, and then we provide either prod development and then up or down. So let's first check if the arguments supplied are correct. So if the first argument is either prod or development, and the second argument with $2 is either down or up, then we will navigate to where the Docker Compose files are located, print to the console the command we are running, and then run the command. If this command is incorrect, then we will print the proper usage of it to the user. So this bash script will run the command right here, docker-compose-f, docker-compose.yaml, -f, docker-compose.dev.yaml, if we supply dev, and docker-compose.prod.yaml if we supply prod, and then up or down depending on which one was provided, which will be here when we capture these inside these variables. And so also, what is this docker compose command? Well, the docker compose command will start up our entire app using everything defined inside the docker-compose.yaml files. The -f flag is how we provide docker-compose.yaml configuration files to the command. The order of which we supply these files is important. The file that is supplied last will overwrite any conflicting information with the first file listed. This is why we provide docker-compose.prod.yaml and docker-compose.dev.yaml after docker-compose.yaml. Next, the command docker-compose up builds, creates, recreates, starts, etc. the services defined inside the docker-compose.yaml files. The command docker-compose down stops and removes containers, networks, images, and volumes that were created with docker-compose up. The bash script we created right here is essentially just a shortcut for writing these long commands. So finally, all we have to do now is run the application in both development and production mode to ensure that it's working. To run in development, run the command .-deploy.sh dev up, and then we get to visit localhost 3000. And you can see the error we get is volumes must be a mapping, so we must have used incorrect syntax. And if we go back into our Dockerfile or docker-compose.dev, look at volumes. And so from looking back in here, it is because we need to add a colon at the end of our named volume. And now if we run the command again, so we can see real quick, running this deploy dev up runs the command docker-compose -f docker-compose.yaml -f docker-compose.dev.yaml and up. So that's just a view of what it does. When we run it now, we can see everything that's running inside Dockerfile.dev. Right now we're installing all our packages. And currently it looks like the port I'm using it with another thing. So what we're actually going to do, and I realize we have to do this anyway, is by default our Webpack dev server will be running on port 8080 unless we specify this. So inside Dockercompose.dev, let's map 8080 to port 8080 on the container. And now we should be able to access this. So let's put up our dev again. We can see loopback running at localhost 8080. And now if we visit this, we get our React app working. So we have hello world. And now we can shut down our container and tear everything down, our images, if we run .-deploy dev down. And we can see that every container was removed, network was removed. And then if we try and access localhost again, we can see we can't get there. And now let's try and access our production. So let's run our production build. And we get container name is not allowed. And it's because we did container name. So if we remove the T here, this should run fine this time. So now let's do prod up. We can see the build command running. We can see the cached other layers that were cached. And -client-build was not found. And I believe this could be, if we look inside our Webpack production file, we can see we have named it dist. And if we change this to build, I believe this should fix this issue. Sweet, looks like we're good to go. And now we just need to access port 8080 on our machine. So let's do this again. And we get hello world, and we can see some output over here from Nginx. And then of course we can tear everything down. We can tear everything down by running our prod down command. But so this is my video on getting a React application running, or a custom React application, by using Docker Compose, Docker containers. I want to thank you for liking and subscribing today, and I hope to see you in the next one. Have a good one.